This demonstration is going to show us how we can take advantage of Power Geopack Select Series 3 to utilize some of our terrain modeling and corridor modeling features to do a preliminary analysis of a new construction project. So the first thing we want to take a look at is making or utilizing a terrain model. We're going to make the assumption that the only thing provided for this particular exercise is a Geopack 10 file or a DTM file or land XML file, basically any type of a file that is providing existing ground data. So the first thing that I want to do then is to make a three-dimensional microstation file that we can import that terrain model information into. So I'm going to select to create a new file, and I'm going to make sure that I have my 3D seed file selected. We'll give this a name. I'll call this existing terrain. We'll create that file and we'll open it. As part of this exercise, one of the things that I would like to demonstrate is taking advantage of Google Earth for imagery in our background. So to do that, we need to make sure that our file that we're working in has the proper geographic coordinate system set. And so that's the first thing that I want to do. So I'm going to come up to Tools, and I'm going to go down to the Geographic category. And I'm going to open this as a toolbox just so that we can get to a couple of these different icons quickly and easily. And the first thing that we want to do is to select the geographic coordinate system. And so we'll select the icon from Library. And I'm going to choose the NAD 83 West Zone for the Missouri Department of Transportation demonstration I'm doing here. And we'll say OK to that. And then I want to just save those settings. We're going to go ahead and close this dialog now for just a moment. And the next thing we want to do now is to build our terrain. So we'll come over to our task, and I'm going to go to terrain modeling, and I'm going to choose to create a terrain model from file. And I'm going to choose the terrain model that I was provided for this exercise. It might already have been done in a DGN file for you, or you might have been given information to import. In our case, we're going to import. With our import dialog opened, if we can go ahead and select our source units, and our feature definition we want to use in this demonstration is going to be existing boundary. And then we select import. And then we can fit this terrain model to our view and close this application. And just to show a couple of things here, if I select on this boundary, I can go to our quick properties and I can change easily the way the terrain model displays. For example, if I wanted to see the existing contours, I can just select existing contours. And if I window in, I'll see the labeling on there. But for our example, I'm going to go back to boundary only. The next step in the process is to project our project into Google Earth and capture that Google Earth image. So to do that, I'm going to go to my tools. And again, we can open this as a toolbox. And we have several icons here. The third one is to export to a Google Earth KML file. So I'm going to do that. And I'm just going to call it existing terrain, and we'll save that. And when we save that KML file, it's going to take us into Google Earth, and that's assuming that you have Google Earth installed on your computer. And it will take us to the location of our project in Google Earth. At this point, we can minimize Google Earth. We want to leave that opened and where it's at, but minimize it. And then we're going to go to our next tool that says to capture the Google Earth image. And so we'll select that. And then we simply follow the prompt down here in the bottom left corner. It says to enter a data point to capture the Google Earth image. And so we'll select that. Now we actually want to see that. And so what I'm going to do is come over here to my view attributes. And I'm going to switch the display style to transparent. And then we can close that. So before we leave this file, let's go ahead and save settings. Now we're ready to make a design file that we're going to use to work on designing our corridors. And so I'm going to select File, New, and And I'm just going to call this planning.dgn, and we'll use the same 3D seed file for this project. That's fine. So we'll save that. With the new file created, we need to go ahead again and set our graphic coordinate system, just like we did before in the other file. So we use the NAD83 West Zone. Say OK, and then save those settings. Now we want to reference in that terrain file so that we can have that as a backdrop for our design. So I'll select File, References, and in the References dialog we'll select Tools, Attach, and I'm going to select the existing terrain file with the interactive selected and set Open. We won't need nesting on this example, so I'm going to turn off my nesting. And then we'll select OK. We can close our reference dialog for the moment, and then we can do a fit view. And now that we have the file referenced in, before we go back to a transparent view, let's go ahead and make that terrain model active so that when we design our corridor, that the slopes or the end conditions can target that terrain model. To do that, I'm just going to use my wheel mouse and zoom in a little bit here on our terrain edge, and I'm going to hover over it and select it and allow the context toolbar to open up, and then I'm going to select my second icon here to set that as the active terrain model. And so now that is an active terrain model, and I'm going to go now back to my reference files, and I'm going to turn off snap and locate so that at this point all we have is the display turned on, which is all that is required for us to design. And then I'm going to go back to my display style and set us back to transparent in this particular view. And so now we're ready to begin our design process. And to do that, I'm going to kind of window in down here in this quadrant. And then I'm going to save settings. With any type of preliminary design, one of the things that we have to think about is the radius values that we use for our horizontal geometry. Power Geopack Select Series 3 makes this a very easy process. All we have to do is to set the appropriate design standard. So we'll come over to our task, and we'll come over to General Geometry, and we have the option here to open the Design Standards toolbar. So we're going to open that up. And then I'm going to select 2-lane or 4-lane. In my example, I'm going to do a 2-lane with 6% super and a design speed of 50 miles per hour. And then you can select based on passing sight distance or stopping sight distance. I'm going to use passing sight distance. And then we want to set that as our active standard at 50 miles per hour. The next thing we have to do is we have to decide what type of pavement structure that we want to model. And to do that, we can access our feature definitions toggle bar. I'm going to go to Design, Preliminary Planning, and I'm going to select Asphalt Pavement 2 lanes here at the top. And I need to turn on 3 icons. This is my active feature setting. This is to auto create a 3-dimensional profile. And then the last icon is to automatically model the template that we've chosen. The way that the automatic 3D creation works is it looks at the active surface, in our case is the existing ground terrain that we imported, and it creates a best fit profile as an initial starting point and then applies that to our corridor that we lay out. You can at any time, of course, modify that profile and see those changes get adjusted. So now that we have our design standards set and we have our proper feature definition chosen and active, we have Auto Create 3D turned on and Auto Modeling turned on. At this point, we simply come over to our horizontal geometry and we have a couple of different options. If we just want to draw a straight line representing our alignment, we can select the line between points. Or if we want to do a more complex layout, where we have radiuses and tangents, arcs and tangents. We can select this complex by PI, which is what I'm going to demonstrate. So I'm going to select that tool, and notice in our MicroStation tool settings that it automatically filled in the appropriate radius value for us, as well as the appropriate spiral lengths based on the standard. It also gives us the option to name the alignment that we're about to place. And so I'm going to leave the initial name in there. And at this point, I simply begin to draw using my mouse. And so let's say that we wanted to mimic an alignment, and you do need to stay within your active terrain, and you'll see that boundary. Let's say that we wanted to approximate a new road starting here. And so I'm going to drag a tangent out and select with my left mouse, and you'll see that the radius is beginning to develop. So I'm going to zoom in here a little bit more, and let's say we want that to go right there. And then I'm just going to do a right click to finish, and we have now modeled that alignment. So let's window in here just a little bit more and see what it gave us. One of the things that, just to show you a little bit, you can make changes at any time to your geometry. For example, I can take this PI and I can literally rubber band it. If I want to modify this endpoint a little bit, I can do that. So there's a lot of different things that you can do once you have this placed. We talked about the fact that when we turn on the Auto Create 3D, that it does a best fit profile to the active surface. So let's take a look and see what that profile actually looks like on this project. So if I come over to Project Explorer, under the Civil Model tab, and I expand my linear elements, I'll find my alignment. I simply right click on that and select Open Profile Model. And you can see I've arranged some views here. It says to select the view that we want to see our profile in, and so I'll do a left data click there. And I will see my existing ground that comes from my active surface, and I will see my proposed profile that is from a best fit. Now if I select the best fit profile and go to the quick properties, you can see that I can make adjustments here to my upper and lower envelope along with my desired crest and sag curve lengths and my minimum curve length. And so if I wanted to try to avoid a lot of cut, for example, maybe I change this to -5 feet and bring that profile up, and in our upper envelope maybe we expand that to 20 feet, and you'll actually be bringing that up more into a fill situation than a cut. If you wanted to adjust your desirable curve lengths, you certainly can, and it will make those adjustments as well. So let's change this to example 18 and drop that down just a little bit. So that's how we can make adjustments to our profile. And if you wanted to do a real profile design, you can select this, and there's an option here to convert this to a ruled profile. And once that's converted to a real profile, then you can make adjustments. You can insert curves, all types of things that you can do on a normal proposed profile design. Now let's take a look at our dynamic cross sections. To do that, we're going to come over to our task and expand our corridor modeling under our civil tools and select Open Cross-Section View. And it asks us then to locate the corridor. So I'm just going to pick my corridor, and then I'm going to select a view to display my cross-sections in. And immediately you'll see my proposed cross-sections. And as I toggle through my project, you can see that horizontal line there is actually coming from our aerial mapping. You can turn that level off if you desire. There are some options here under View Properties. If I wanted to see, for example, my cut and fill graphics and those values for earthwork, I can turn those on. And then as I toggle down the job, I can see how much volume I'm taking up on this particular job. Turn those back off. If we hold down our Shift key and use our wheel mouse, we can stretch vertically. Our Control key in our wheel mouse, shrink and stretch horizontally. And no key down, wheeling in, moves in and out around the point that we are. You can type in a particular station. You can advance one station at a time, proceed all the way to the end, or all the way to the beginning. If you do a right mouse click, you can select to locate station by data point, select in my plan view, and then navigate to a location you want to see a cross section. If I do a right click, I also have the ability to place a temporary dimension line. So for example, if I wanted to evaluate how much of a fill distance I have, I can select that, and you can see I have the distance and the slope value as I proceed down my job. And so these are some things that we can do in our dynamic cross-section view. And just a little tip, anytime I'm in a command and I want to get out, I can press the escape key or F4 function key in the mode out workspace. And just one thing to show, if I select my geometry here and I move, that dynamic cross-section view is going to update as quickly as my alignment updates as well. And so I can make those changes to the geometry and see those updated cross-sections. The very last thing I want to show in this video is how can I determine the quantities that I'm dealing with. At any time I can select my corridor, and on the context toolbars, one of the items right here is corridor component quantities. And I can look at other reports as well. But if I'm just trying to get some rough quantities, I can select this and it'll open up the component quantities dialog. And at this point, it either gives us a surface area, for example, our area of ground proposed, which would represent our seating area, or it's going to give us a volume of cut or fill. And immediately we can see that this particular job, based on the location of my profile, doesn't have any cut at all. It's completely a filled job. And we can then adjust our unit cost based on the units that were provided and see the cost, the rough preliminary cost of the particular project at any given time. And so if I come in here and put numbers in, and let's just make something up here just for demonstration purposes, you can see that total estimated cost based on the components of that particular corridor. And so you can see here that we're at this dollar amount. And what I'm going to do, just to show you the dynamics of this, let's go ahead and go back to our profile design. And remember, we did that in Project Explorer. Right click and open profile model, and we'll select that. And I want you to watch what happens to the quantities. I'm going to select our profile, and I'm going to make an adjustment here by dragging this down. And as soon as I do that, the corridor is going to update, and the component quantities will refresh once we come back in. So if I select our corridor again, we go to our reports, component quantities, and you can see we significantly reduced the cost of our project just by lowering that profile based on the fictitious unit cost numbers we put in. We removed a lot of our fill quantity requirements and have now only just a little bit of cut, and it made a very large difference on the cost of our project. And let me emphasize, this is intended for obviously preliminary design. And I think it's obvious that there's a lot more to designing any roadway project than what we're doing here. But this is very powerful to allow you to get a rough idea of what you're looking at in terms of the cost of a project based on the terrain that is there, the particular typical section that you choose, etc. And one of the nice things about this is if you did want to look at a different particular typical section at any given time, you simply select your template drop here, and right now we have picked this particular template. If I wanted to switch this over, for example, in, let's say I wanted to use concrete shoulders, and I select that, it's going to remodel based on that new template information, and now we would have the concrete shoulders. And so if I selected my corridor and go back to my component quantities, you're going to have a new entry in there that represents our concrete shoulder, and you will see it right there. And of course we would need to put in a value here, and we would see then the differences in the cost. Again, I cannot emphasize enough the power that is here, but also understand that this is a preliminary design process to allow you to do some conceptual analysis in determining what it would take to build a particular road corridor in a given area.